Hello, everyone, and thank you for joining today's webinar. We have quite a few people still logging on, so we'll give them a chance to get settled, and we'll get started in just a few minutes. Thanks. All right, hello, everyone, and welcome to today's webinar, Automating Unstructured Content Workflows with Intelligent Process Automation. My name is Jeremy Stinson, and I'll be your moderator. I work on the marketing team here at Indico, and I'm excited to be hosting today's webinar. First, I'd like to take a moment to introduce today's presenters. Sarah Burnett is an Executive Vice President and Distinguished Analyst at Everest Group, where she leads the firm's Service Optimization Technologies research program globally. As part of this role, she researches and advises clients on automation technologies such as robotic process automation, artificial intelligence, and global service providers' capabilities in the field. Based in London, she also serves European clients across Everest Group's European-focused global services research areas. Tom Weil brings 25 years of experience in solving the complex problems of digital content to the role of CEO of Indico. Prior to joining Indico, Tom was the Chief Product Officer at CSense, a leading data management provider and founder of RAMP, an enterprise video content management company. Tom also held senior roles at FastSearch, Miva Systems, and Lycos. He has extensive experience with company building and venture-backed startups, and holds an MBA in entrepreneurial management from Wharton. Now, without any further ado, I'd like to turn it over to Sarah Burnett.
Thank you, Jeremy, and hello, ladies and gentlemen. Tapping into AI technologies to automate everyday processes creates many exciting opportunities. This is a really dynamic market to be in, and I'm really excited to be here today to talk about some of the important aspects of AI when it comes to automating content-centric processes. This slide shows the topics that I'm going to be talking about in 3 sections. Firstly, an overview of automation in the enterprise. Then I'll focus on automation of document-centric processes and examine the typical workflow for that. And I'll finish by talking about how automation technologies can help. So to begin with, let's have a quick overview. Next, please. The key issues driving automation in the enterprise are shown in this slide. I'm sure many of you are familiar with this. Going clockwise, the first thing is the cost of operations. This tends to be high because often people with varying degrees of specialist knowledge are involved with handling documents. And just take the case of invoice processing. Although you don't need a huge numbers of years of experience in order to process those documents, you do need some degree of knowledge. When the volumes are really high, you're getting a lot of incoming documents and you don't need a lot of skills. This kind of thing becomes quite tedious, and this is where human error starts to creep in, and also people literally get bored, and sometimes you might end up getting a lot of staff attrition as well. Checking invoices is a good example of this kind of thing, this kind of creeping boredom factor. Another example is checking incoming customer inquiries, be it emails, text messages, or letters, reading the content, understanding it, and deciding what action to take next. For example, who or which department should handle the incoming information. The subject of these different formats also leads me to some of these next items on this slide. There's this case of handling heterogeneous data formats, which rules-based technologies such as RPA can't really handle. So in comes the need for intelligent document processing, intelligent technologies. The result, if you don't do these kind of things, if you don't use these technologies, what we have today, which is a lot of manual processing, and that of course results in long turnaround times. Next, please. So these technologies, RPA and AI together, they become intelligent automation. You may have heard that term talked about a lot in the industry. These are the sort of typical differences between the two. They're highly complementary. There's not a question of one replacing the other. It's just a question of what's the sweet spot for each of these types of technologies, and together they offer incredibly powerful capabilities to enterprises. With RPA, we get the fact that it's mimicking the user activities on the keyboard, and also it's rules-based and processing largely structured data, sometimes maybe handling some semi-structured data, but it's rules-based, and pure RPA doesn't have any inherent learning capabilities. So unless the technology vendor has integrated it with other AI capabilities, it's not going to have any learning capability. AI, on the other hand, is trying to mimic the human thought processes and can learn or improve its performance over time. And so the main thing is it can handle those incoming documents, the unstructured data that comes into the enterprise, and together, really, they're a marriage made in heaven. Next, please. Some of the benefits to expect. If you imagine organizations, maybe your organization is one of them, which has to handle absolutely millions of incoming documents a year. Maybe you're checking not just invoices, purchase orders, or maybe you've got to check a lot of know your customer type of documentation, a lot of evidence submitted as part of insurance claims, or maybe you're dealing with a lot of healthcare information that doctors may have provided about their patients, patient notes, and those kind of things. Then there are companies that have to check thousands and thousands of financial documents, extract key information from them. And the other thing is that by augmenting the workforce, these technologies actually improve their productivity, so get them to do more interesting, more judgment-intensive type of work where they can use their skills better and perhaps remove some of that boredom factor. And then the other thing is that you can handle any type of document in using these types of technologies, and by digitizing them effectively, you can create proper management systems for your documents, so you can streamline the document tracking systems and processes that you have in the enterprise. And over time, these machine learning algorithms, they learn and their accuracy increases. Some enterprises are now reporting over 90% accuracy with intelligent document processing tools. And of course, you can embed compliance and governance requirements into the process, and also improve the turnaround time, so improving not only the cost but some of these other benefits that could make a big difference to the bottom line. So let's move on to the next slide, and here, before we go any deeper into this topic, I'm providing you with a definition which is about intelligent document processing. This is basically Everest Group's term for this group of technologies, and we call this IDP for short. It's any software or product that captures data from documents, emails, texts, PDF, and scanned documents. It then categorizes and extracts relevant data from them. And typically they're using AI technologies such as maybe computer vision, some machine learning, natural language processing, and so on. They typically integrate with other systems through APIs as well. So let's have a look at the sort of typical features that these offer. On the next slide, you'll see that what we expect to see in these kind of in these solutions, in a sort of enterprise grade solution, is shown here. And this also captures really the workflow, the process, and I'll come back to this in different representations of this. I'll come back to it later. But here, you should be expecting the IDP to capture data from various types of document, then classify them into categories, extract relevant data for further processing. Under the hood, in the middle layer there, you see the kind of technologies that are powering these features. You see that there's OCR, text mining, and natural language processing. Some of these can also offer capabilities such as noise reduction. So if you get an image of a document which is fuzzy with maybe some sort of unclear text, they can actually enhance the text and remove some of the noise. They can have predefined taxonomies and rules for validating data, and be trained to handle different types of documents such as invoices, purchase orders, contracts, and so on. Let's move on to the next slide. Here are some examples of use cases. I've mentioned some of these already. There's the Know Your Customer in financial services, insurance claims I've covered, bank statements. Banks send out huge numbers of statements, millions of them every year, and the opportunity there is great. In healthcare, just imagine how much better it would be if doctors could easily access the latest research and development in medical care and medical science, and be able to apply those in care of their patients. And this type of automated processing of those R&D research reports could make a huge difference to care. Patient records, I don't think we're yet at the point where we can process doctors' handwriting. I think that's quite difficult to achieve, but certainly where there are free form handwritten notes, then I think that's free form typed in notes rather than handwritten. It's definitely going to make a difference. In CPG and retail, manufacturing, travel and logistics, there's a lot of documents going backwards and forwards, order forms, proof of delivery, custom declarations, and so on. Again, this technology is ideal for these type of use cases. Next, please. So that brings me to the second part of my presentation, and this is focused on intelligent document processing. And you'll see on the next slide that I've represented that workflow slightly differently this time. I'm looking at it in terms of certain steps. So earlier we had a look at document processing workflow from the point of view of the features that you should expect in enterprise software. This is the step-by-step view, begins with data ingestion, which involves document capture from multiple sources. This could be from websites, portals, physical documents, mobile devices. faxes and emails. That you can have different types of inputs, so there might be structured, semi-structured inputs, because these technologies are capable of handling those. They could be from Excel or form-based structured content. Going back again to the example I gave, know your customer type of data, and semi-structured content such as invoices. Then there's the unstructured content as well. These include things such as unstructured documents. Contracts are a good example of that. Then you might get raw texts and tweets and emails, the body of the email that is unstructured. The next step in the document processing workflow includes classification, and then you get the data extraction. There's validation to be done, and the final output goes into another system. So either through APIs, so you might be feeding the information into an ERP system, into a CRM system, or via an RPA tool that does the integration for you and enters the data into whatever system it is that you want to use to process the information that you've just captured. If we go to the next slide, you'll see that at the moment what we have, sorry, I'm one slide behind. Yes, this is an interesting definition of OCR and some of the shortcomings of it. The question that I get quite regularly is, we've got OCR, why do we need IDP as well? This slide shows some of the features and limitations of OCR. Let's start at the top. OCR converts images of documents into machine encoded text and extracts specific fields based on specific templates. IDP, on the other hand, may use OCR to convert images of documents to digital format, but it can extract specific information using machine learning and or deep learning as well. OCR uses rules-based or template-based extraction. The user needs to train the system for each template type. With IDP, the extraction doesn't depend on the template, but on the content. So there is some training. Of course, I'm not saying there's no training, but it's sort of really minimal compared with OCR. OCR doesn't classify documents into different categories, but IDP can and does. With OCR, you need to manually review every converted document, unless the input documents are very standard in terms of quality, the positional elements, and so on. With more intelligent solutions, once the system is trained, basically straight-through processing can be enabled. The percentage of STP, the straight-through processing achieved, can vary, but you can get better over time and make it more and more independent to operate. OCR can't assist the user while reviewing the extracted information, but IDP solutions can assist human workers and agents while reviewing errors by providing suggestions as well. OCR can't really do unstructured documents such as contracts and emails. IDP can. So just a quick definition of, highlighting of OCR key features and differences with IDP. Let's go back, let's go to the next slide, and this gives you a different view of the same document process flow that I've been talking about. This time I've added the benefits of it. So if we look at these three streams that are coming in down from the top towards the bottom of the slide. Firstly, we have the document capture, which is enabled by technologies such as OCR itself, other computer vision type capabilities. And this helps you generate responses automatically using the technologies that I've been talking about, and typically in natural language format. And of course, what that does is enable you to respond to customer emails and tweets and other interactions faster and more efficiently. There's also the opportunity to do some sentiment analysis, and natural language generation capabilities that do the responses for you often in typically the simpler types of communications. Then in the middle there, we have the classification stream, which is using text mining and machine learning again, generates summaries, so it can do some analysis of what's coming in and provide you with a dashboard type of information about what's going on. And that can provide the enterprise with some insights and even lead to descriptive, predictive, and different types of analytical capabilities. So prescriptive could be possible as well. So basically what that means is that you can see, maybe see where the issues are arising from. Maybe you're getting a lot of complaints about a certain thing, or maybe you're getting some kind of breakdown in a system or in a product that you're offering, and makes it easier when you've got a lot of products, a large portfolio of products, you've got a lot of different offices in different geographies. So being able to sort of tie some of this information together, join the dots, and actually see what is going on in the enterprise, it would help with that as well. And then there's the data extraction part, which leads to the actual processing of information. This is really the core part, the heart of the process. And this is where you're sort of employing NLP type capabilities, machine or deep learning capabilities. The this uses integration capabilities with pre-built connectors to feed the information into downstream systems. And again, these could be ERP type applications, enterprise applications, and where you don't have connections, there's always RPA that allows you to connect to those systems. Next, please. Yes, so let's jump to the next section of my presentation, which is really more focused on the kinds of intelligent components and constructs that power the intelligent automation capabilities that I've been talking about. So if we go to the next, you'll see that I've highlighted here OCR and the more intelligent version of it, ICR, computer vision, machine learning and deep learning models, and NLP. I've already really talked about OCR. You get some more intelligent built into it. You hear the term intelligent OCR as well. So some degree of intelligence built into that. So some of the capabilities that IDP solutions do are also offered by those intelligent OCR capabilities. But this is about the sort of the more complete picture, the stronger, more superior capabilities. Computer vision enables automatic extraction, analysis, and understanding of useful information from digital images. There is machine learning and deep learning, which is about intelligent automation solutions using these to classify and extract documents. These are basically I'm talking about the algorithms that are used for training and refining models and so on. Of course, in these types of software, a lot of that work has been done for you by the software vendor, and Tom can tell you a lot more about those. Some vendors actually do their own, some use standard algorithms that are available out there in the market. And then there's NLP, with the help of which you can analyze running texts in documents, understand the context, consolidate extracted data, and map the extracted fields to a defined taxonomy. They can also recognize sentiment from emails and other unstructured data and classify them into different categories. So a lot of computing capabilities are there for enterprises to tap into. And on the next slide, you'll see different approaches to learning methodologies. So there we have supervised learning is one approach, which is all about the initial setup learning. This is done by AI ingesting labeled sets of sample documents, These could be in Excel files with sample data in order to learn to classify documents and extract the relevant fields. There's continuous learning. This is done through corrections made by business users during manual reviews, which are really fed into the system, generating training batches in the background. An important aspect is for the business users to train the software by defining the criteria through anchors, associations, expressions, lookups, and so on. There's pre-training. This is leveraging machine learning models trained beforehand for particular users to accelerate deployment. We often hear about the challenges of training intelligence solutions, having to have a lot of training sets and a lot of samples for the machines to learn, basically. So these are some of the approaches that are being used to speed up the learning process. And finally, there's the rise of transfer learning, and this is a very interesting development. I just wanted to touch on this. This is coming about again because of the same thing, the issue associated with any AI-based solution that requires time for it to learn and handle exceptions, and this slows down the process. The AI engine has to understand thousands of use cases before it can be employed in a real-world scenario. However, I think with this kind of solution in sight, and again, Tom will be able to tell you a lot more about this, a machine learning model using transfer learning enables trained model for one task to be used as a template or a starting point for another, thereby saving time and effort. So that brings me to the end of my presentation. I'm going to stop there and pass the control back over to Jeremy. Over to you, Jeremy.
Great, thanks, Sarah. And I think that's a perfect segue to now hand it over to Tom to talk through Indico's point of view on how to handle unstructured content processes. Tom, over to you.
Thanks, Jeremy, and thanks, Sarah. So for this section, I wanted to walk through some of the particulars of approaches that Sarah touched on, specifically transfer learning as a means for solving document processing and document understanding. Indico is a Boston-based technology firm that's developed an application using an approach called transfer learning, and our sole focus is on helping our customers automate document-based workflows. The big challenge with unstructured content, broadly speaking, in the enterprise is there's just a vast amount of unstructured content. And for the most part, very little of it has been activated with traditional technology developments. Most of the products that have been developed over the last decade have focused on structure. And so very little of this unstructured content, specifically documents, benefits from this investment that we've seen. And inside all of this unstructured content, the way customers describe it to us is a vast amount of opportunity that is difficult to tap with traditional approaches that I'll talk about. And secondly, risk. In this age of things like GDPR and regulatory risk and information protection, understanding what's in your unstructured turns out to be as important as what's in the structured data. So we get up every morning to solve this. We are focused on this unstructured problem. And by and large, when we walk into a customer opportunity, what we see is rather than us replacing an existing solution, we're finding much more like a assembly line of people performing these tasks manually. So these documents are passing from person to person, where they are reviewing, classifying, extracting key information, all to drive a particular process. What happens then is you have what we call an individual understanding of the process rather than institutional understanding. Because people are doing these work, you get quite a bit of variance and inconsistency and even error. When you apply automation to these tasks, you're wringing out a more consistent process and a more cost-effective process. And that's really the benefit that we drive with customers, is wringing out risk and allowing them to tap this opportunity using automation type strategies. One of the misconceptions of AI in general is that AI will come in and displace wholesale a large number of employees. That's just not been our experience. Much more common is for the customer to describe a desire to create almost a bionic arm for their knowledge workers, enable their knowledge workers to have some form of superpower in the form of scalability and speed. That's really the right way to think about AI, and what you're able to capture with AI approaches like transfer learning, which I'll talk about in more detail in a moment, are these kinds of benefits. Sarah touched on several of these, but certainly efficiency, decreased cycle time of document workflows, which often has a very positive impact on the customer experience, redeployment of high value resources. A lot of times these workflows are being done by very skilled people because the requirement that there's judgment involved in understanding these documents. What AI enables you to do is create what we refer to as scalable decisioning. And then finally, decrease risk. You get a much more consistent process when you apply these kinds of augmentation and automation approaches. So let's dig in a little bit to this particular technique called transfer learning. Before I do that, I think it's important to describe why deep learning is such a transformative technology for this category of the market. And a lot of times I have people ask me to describe in very simple terms the impact of deep learning, not technical terms, but simple sort of business terms. And the way I answer that question is as follows. For decades, and because unstructured content is not a new problem, for decades we've been using what's called some form of rule-based or expert-based system to try to comprehend unstructured. The problem with rule-based systems is you have to go into excruciating detail on a software development standpoint to articulate all the possible edge cases and parameters of the content ahead of time. The problem with this is you often don't know all of the variability of the content you're going to be dealing with. Deep learning arrives, and for the very first time, we're able to invert that problem statement. What deep learning does is say, show me the outcome you're trying to achieve, show me example inputs, and I will backwards solve to find the answer, to create this algorithm, this decisioning inside these neural networks, which is what deep learning is based on. Now, the problem with deep learning is it's a very smart learner, but it's a very slow learner. You need millions of examples of the given task you're trying to automate to teach it how to perform that task at human proficiency levels. What Indico has done using transfer learning is build a giant generalized model of language. This enables us to create a huge context space to allow our customers to build small custom models with only about 200 labeled examples to create proficiency around these particular tasks. The reason for this, and this is another shortcoming of the traditional rule-based or regex-based or OCR templating-based systems, is that for the longest time, we've tried to use keywords as a means to understanding unstructured content. It turns out that keywords are not a particularly good approach for understanding unstructured, simply because keywords are not the answer, context is the answer. So the problem shifts to the question of how do I get the context at a robust level enough to be able to, quote unquote, solve these tasks I put in front of the AI. The transfer part in transfer learning is with Indico, our customers are able to transfer the general knowledge of language, the context, onto the specific knowledge they provide with these 200 labeled examples that they build within our point and click application called Indico IPA, Indico Intelligent Process Automation. One of the big mistakes that we think has occurred in the market prior to Indico is too many solutions, AI solutions are focused on the data science persona. The reality is with AI, it is a garbage in, garbage out problem. The biggest challenge you have is capturing high enough quality labeled data to teach the AI how to accomplish its task. The issue is the subject matter experts or the analysts are the ones who know the data and the workflow the best, typically not the data scientists. So we built Indico IPA to put in front of analysts and subject matter experts a point and click ability to label data and create these custom models with very little or no knowledge of data science, and then stitch those together in a building block metaphor to automate these kinds of complex workflows. One other benefit of transfer learning, as most of our customers require us to install this in their cloud or on-premise, because for the most part we work with financial services and insurance, is transfer learning is very compute efficient. If you start to look into deep learning and AI in general, you'll find that it can be very, very compute intensive. We've solved this with transfer learning as well. Only the generalized model sits on the GPU, which is a heavy duty processing server for high capacity mathematical computations required by AI. and all of your custom models scale out on CPU. So it's very efficient from a compute standpoint. And the way this gets implemented in practice is you're able to, with Indico IPA, ingest content in any kind of format, so PDF, Word, CSV, and it can come from any kind of source format, Box, Dropbox, SharePoint, Salesforce. That content runs through the custom models that you build within Indico, and out the other side, you get structured data, JSON, XML, CSV, which you can then inject into your target enterprise platforms. Essentially, we're turning unstructured into structured. We're effectively giving you a programmatic interface into this river of documents that you have in the organization that your downstream systems are requiring and expecting structure in order to execute their functions and their business logic. So that said, let's go into a specific case study here of a customer who's employed the Indico approach to solve one of these unstructured content workflows. So Chatham Financial is a global financial technology firm working in the debt and derivatives market. They process over $500 million in annual transaction volume. And as you'd expect from this kind of work, they deal with a lot of documents. Their business is helping to work with counterparties to make these transactions and trades happen. Well, the issue is when you're dealing with lots of counterparties, there's a lot of documents changing hands. They flow into Chatham, where Chatham, on behalf of its customers, assists with making these executions effectively executed with high accuracy and timeliness. And up until Indico, they would have been doing most of this processing on a manual basis. They had subject matter experts who would review these trade orders, extract information and key it into a downstream system in order to make these trades happen. With Indico, the key requirements were, how do we turn this manual process into an automated process? We've got heterogeneous documents coming in, mostly PDFs on counterparty forms. Yep, and these often came in via email, most often, and they would have at times long turnaround times if the volume built up and was sort of spiky or lumpy. The desire here was to increase the throughput and reduce the expense per transaction. So what we did was we took the Indico solution and we applied it with Chatham towards this extraction challenge. So we had the inbound documents coming into the organization, PDF by email. We created these custom models by labeling about 200 of these sample trade confirmations, a general cross-section of the sample trade confirmations they were receiving, to build this extraction capability. Now, something very important here to emphasize, there were no rules or regexes that had to be written to do this. We also didn't have to create a custom model for every counterparty. We created a general custom model, training on a cross-section of sample trade order confirmations to be able to build this extraction capability, which ultimately extracts several dozen key value pairs that get injected into their downstream trade systems. You can see on the right just an example of the structured format that we were able to derive from this river of trade confirmations, and that gets then transformed and injected into their downstream systems. And this worked. So high variability of inputs, right? You had scanned PDFs. So part of the Indico solution is OCR and then the extraction. We can handle heterogeneous formatting, and this resulted in a dramatic increase in the throughput of these transactions by giving Chatham this very robust augmentation/automation approach for this very important category of transactions. And the Indico approach, as sort of a building block approach, allows Chatham now to apply this same approach to automate other workflows they have inside the company, and they have half a dozen other key document-based workflows that they're looking to automate as a next step. And the nice thing is the Indico platform allows you to do that. So this doesn't require a point solution, and our generalized model can span across a very wide set of use cases and industries, and enables you in a very short period of time to create these custom models with just a small amount of training data. So that's the case study and the Indico overview. We wanted to now turn it back to Jeremy to MC Q&A. So if you have questions, I think you can load those into the question pane within your console, and we'll be tackling those questions between Sarah and myself.
Awesome. Thanks so much, Tom. As Tom said, now we're ready for the Q&A segment of today's presentation. So if you do have questions that you'd like to ask our presenters, feel free to use that Q&A tab at the bottom right-hand side of your screen. So we'll give folks just a few minutes to get those questions populated. All right, it looks like we have our first question here. This one asks, are you seeing RPA vendors take a build or partner approach to solving unstructured content? Sarah, I'll toss that one over to you.
Yes, sure. So seeing both. RPA vendors are either working with their partners to integrate their different capabilities so that you can do end-to-end processing. Some are developing their own, and I would say the balance is probably more on the integration side, integrating with partners, but it is a mix, there's a mix of approaches in the market.
Yeah, and I would add to that because we get this question very frequently, which is, can you distinguish RPA from IPA or IDP? And we certainly see them as highly compatible. I would say that, about half of the time we're implementing alongside an RPA solution, and about half the time it's a standalone solution. Clearly, document automation is a key part of an overall automation journey that the customers go through. Yeah.
Great, we've got another one here that asks, can you give us an idea of the most common unstructured content use cases that you see? Tom, I'll let you take that one.
Yeah, I would break them into maybe a couple big categories. So at the high level, we see what I'll call semi-structured type use cases and unstructured type use cases. Semi-structured would be things, and I think Sarah touched on this in her presentation, things like invoices, forms, those kinds of things are semi-structured. A lot of times they're still scanned PDFs and need to be extracted and classified, but the data has some structure present. Then there's unstructured categories of use cases. These are things like contracts, policies, and longer form documents where you're talking about free text that has to be interpreted, classified, and extracted in order to derive value from those kinds of documents.
Great, thanks, Tom. We've got another good question here. There's so much noise around AI in the marketplace today. How can you tell when a vendor has real AI technology? Sarah, I'll let you lead with that one.
Well, I think for me, the differentiator is probably the ability to learn and enhance the way that it processes things. There are many different kinds of intelligence when it comes to software. So you could have AI that doesn't learn, but I would say that's more like an autonomous, more like a rules engine and rules-driven approach, whereby you do have to change the rules if something changes in the process. So I believe really genuine AI has that learning ability and being able to modify its behavior over time and increase its the benefits that it returns. I think that's really important.
Yeah, and I would just build on that. I think that what we see in the market is, when you think about RPA, it's generally deterministic, task-based type automation. On the AI side, you're typically talking about what we describe as fuzzy problems, right? So natural language processing and document understanding is clearly a fuzzy problem, and therefore probabilistic. And the thing that AI brings to the table is what we describe as scalable decisioning, which kind of builds on Sarah's point about learning, right? So it's the ability to learn yields this positive benefit of scalable decisioning. Because I think that the big thing we emphasize with AI in terms of what it's good at, AI is really good at scale and speed. And I think that there's some misconception in the market that AI is also going to be good at sort of inventing new approaches to solving your problem. And that is still, very early days on the AI side. AI is best thought of as scalable decisioning with speed. And pairing that with RPA and pairing that with your subject matter experts yields the most impactful results, with a reasonable amount of effort and therefore, high ROI.
Great. We've got another really good question here. This attendee is asking, we understand Indico has a specialization in unstructured documents. Have you tried extracting data from complex tables?
That's a great one. So tables represent one of the most difficult sort of categories of unstructured extraction in the market. So Indico is able to support heterogeneous table extraction and table identification. I would also add to that that this is probably one of our biggest areas of R&D, because if you look at enough documents, you realize there is no limitation to human creativity in creating tables, and therefore, makes it an extraordinarily difficult problem in a heterogeneous environment. Now, if you have tables that are highly homogeneous, such as internal documents with a template, those actually can typically be done with a more traditional rules-based approach. But in a highly variable environment, table-based data is both very valuable and very difficult, so a strength of ours.
Great, thanks. Another good question here. How do you suggest we go about solving for AI explainability internally? This has been a challenge for us. Sarah, do you want to start with that one?
Yes, I think that is a challenging thing. Perhaps it's important to give it test data to show that, first of all, to help you understand how it's going about doing its calculations and coming up with the answers. It's important to make sure that it is unbiased in terms of the way that it processes the information, and there are ways of actually testing it for those. That often the algorithms that are used in defining the models and so on, they are standard algorithms that are out there, but I think it's probably important to test the algorithms with known data sets and examining the outcomes, the outputs from the system. It is a difficult thing, and you do need transparency. In certain industries it's more important than others. I think it's important anyway, but I do know this is a challenge for highly regulated industries.
Yeah, and I think that both bots and AI represent a whole new category of governance within major enterprises that frankly is still being figured out. Our view at Indico is you should require your solution provider to be able to give you access to the key metrics that explain what the AI is doing. If they can't do that, ultimately that solution is not going to be successful within your organization, because the compliance and governance folks, in the very near future are going to be requiring these kinds of metrics before they'll certify solutions using AI. So you should require that your technology partners provide access to the explainability of the AI in question.
And Tom, am I right in thinking that in certain cases you can actually have the algorithm checked by a regulator and approved?
Yes, and the regulators increasingly will ask for a standardized set of metrics, and this gets a little bit into data science, but precision metrics, recall metrics, F1 scores, these are sort of data science best practices that should be provided by any technology solution you use. And on Sarah, your point about the testing piece, also important that there are blind test sets built into the testing algorithm so that you avoid what's called overfitting, which is using only your test set to make sure the algorithms are working. You need blind test sets to confirm that the algorithms are working. And a blind test set meaning a test set that the algorithms have never seen before. So very important set of governance issues. Yeah.
Yeah.
Awesome. So we've got actually two really good questions here that are kind of related. So I'm going to read both of them, and then Tom, I'll let you take a stab at this. So the first attendee asks, how do we generate labeled data? And then the second question, which is related, is I completely agree with the statement made about garbage in, garbage out. But how do we realistically overcome this without investing too much effort in tagging and labeling data?
Yeah, so I think the big challenge to overcome, which is sort of the centering, reason for Indico's founding, is how to take advantage of deep learning type techniques without the enormous burden of the training data that is associated with it, which is just, there's no way around it, right? Deep learning requires a large amount of training data. Transfer learning breaks the back of that by splitting the task into a generalized training approach, which Indico brings to the table, as part of our application, and a specific training approach, which is the data labeling task. With Indico, you only need about 200 labeled examples, But one of the things we found early on was when we asked customers for 200 labeled examples, they all said, well, how? Where do we do this labeling? How do we give it to the algorithm? So that was part of our product investment, was to build an interface that allows a subject matter expert or analyst to load a set of test documents and then just with point and click, do the annotations and classifications in line to build this high quality training data. If you're able to do that, you dramatically increase the probability of success of an AI deployment and minimize the burden on the organization of having to go find 1 million examples, which, you know, I've never ever seen that be possible. So that's really the focus here of, you know, Indico seeks to bridge this gap between the academic reality of deep learning, which is, you know, built in a laboratory, and the practical reality within the enterprise where data is messy, data is hard to put your hands on. You know, you need to get subject matter experts involved to understand the data and the process, while still bringing this very powerful technology to the table.
Awesome. Another question here, Sarah, I'll let you take a stab at this and then toss it over to Tom, but this attendee is asking how to go about identifying a potential use case to pilot for IPA.
Well, I think there's types of characteristics that identify a process that might be suitable for using intelligent process automation, using this kind of IDP. There are, you know, there are methodologies that help with identifying them, but basically the sort of characteristics to look for is the repetitiveness, the volumes, how much comes in, whether you're looking on the transactional part of IPA or on the very content-centric IPA. Then you have to look at, you know, is it a lot of transactions coming in that are using structured data, you know, and then sort of filtering those for rules-based kind of automation? Is it a lot of information coming in that is unstructured and a lot of man hours or human hours are being used to handle those? So it's really looking for the core characteristics and having a recursive methodology that narrows the field. We do have one, it's called EFCA, basically enterprise value chain for selecting processes, and you can literally look at the process pyramids that you have in your enterprise and recursively filter them for identifying the correct one for the different types of automation possibilities that are out there.
Yeah, and I think that just to add to that, we really push customers to sort of start at the end and work backwards as an approach, meaning be sure you can define what success looks like, meaning that the outcome is going to be business impactful. You know, define what the data looks like that would create that kind of success, and that allows you to work backwards and figure out what is the training data I will need, what is the automation approach I need, how complex is this task, what systems will consume the output. And that allows you to kind of frame the problem and ensure that when you step into the use case, you know what success will look like.
Nice. Okay, I think this is a great question to end on. Actually, again, we have two that are semi-related, so I'll combine them. The first attendee is asking, what's the turnaround time if one were to dig into a new domain/use case? And then the second question asks, what does the engagement model with Indico look like? So Tom, I'll let you take that one.
Yeah, I think that what we see is it's pretty common for the very first use case when you're trying to solve unstructured with AI, that start to finish, it may take you, about 90 days from the point of definition to the assembly of the training documents, to the building of the models, to the testing. The nice thing though is what we see is the second use case often happens within 30 or 45 days. So you get this really nice acceleration once you kind of wrung out your approach to doing that. From an engagement standpoint, we always require our customers to do a proof of concept where we get a small amount of training data, we define a particular use case, and we show that AI can solve it, right? And we do a lot of vetting up front to make sure that the use case is appropriate and guide them in terms of how to think about using AI. What is AI good at? What is it not good at? What is its capabilities? and how to understand ROI. So we actually even have an ROI calculator where we collect a bunch of inputs from the customer, and we confirm before we even start that if the use case is successful, there's a real bottom line impact to that success in terms of dollars and cents. So that's a key part here. Really help think through the business impact of this before we start to worry about the technical impact and the technical approach, assuming automation is going to be successful. So that we found to be extremely effective.
Awesome. Well, we are just about at the hour mark here. So again, if there are questions we didn't get to, look for a follow-up email from us where we'll answer all of those questions. And with that said, I want to thank Sarah for joining us today.
It's been a pleasure.
And thank you, Tom, for joining us as well.
Great, enjoyed it. Thank you, Jeremy.
And thank everyone on the other end there for attending. We hope you found the content useful. And again, look for a follow-up email from us that will have all the content, the webinar recording, as well as a few attachments on today's topic. Thanks again, everyone. Have a great day.
Thank you.